Now there's one more manipulation of integrals that gives us the fanciest property of the log. And that's the last one that I'm going to do. And you have a similar thing on your homework. So I'm going to prove that this is, as I say, the fanciest property of the log. On your homework, by the way, you're going to check that L of 1 over x is equal to minus L of x. But we'll do this one. The idea is just to plug in the formula and see what it gives. On the left-hand side, I have 1 to AB dt over t. That's L of AB. And then that's certainly equal to the left-hand side. And then I'm going to now split this into two pieces. Again, this is a property of integrals, that if you have an integral from one place to another, you can break it up into pieces. So I'm going to start at 1, but then go to A. And then I'm going to continue from A to AB. So this is the question that we have. We haven't proved this. Well, no, this one is actually true. If we want this to be true, we know by definition L of AB is this. We know, we can see it, that L of A is this. So the question that that this boils down to is we want to know that these two things are equal. We want to know that L of B is that other integral there. So let's check it. I'm going to rewrite the integral. It's the integral from lower limit a to upper limit ab of dt over t. And now, again, to illustrate properties of integrals, the key property here that we're going to have to use is change of variables. This is a kind of a scaled integral where everything is multiplied by a factor of a from what we want to get to this L of B quantity. And so this suggests that we write down t is equal to a times u. That's going to be our trick. And if I use that new variable u, then the change in t, dt, is a du. And as a result, I can write this as equal to an integral from, let's see, dt is a du, and t is au. So I've now substituted in for the integrand. But on top of this, with definite integrals, we also have to check the limits. And the limits work out as follows. When t is equal to a, that's the lower limit. Let's just take a look. T is equal to a times u. So that means that u is equal to what? It's 1. Because a times 1 is a. All right, so t equals a. This is if and only if. So this lower limit, which really in disguise was where t is equal to a, becomes where u is equal to 1. And similarly, when t is equal to ab, u is equal to b. So the upper limit here is b. And now, if you notice, we're just going to cancel these two factors here. And now we recognize that this is just the same as the definition of L of B, because L of x is over here in the box. And the fact that I use the letter t there is irrelevant. It works equally well with the letter u. So this is just L of B, which is what we wanted to show.